design the three-tier architecture where this is the structure of the project. It will have one VPC and one internet gateway and one NAT gateway. Internet gateway is connected to the public subnets and NAT gateway is connected to the private subnets. In the public subnets, there will be a front-end application is running. In the private subnets, it will be 4 private subnets. In the private subnets, 2 is for backend application and 2 is for database. And today I'm going to design that architecture. Both it will have three-tier architecture, and I'm going to develop that now. First, we need to VPC. VPC is nothing but isolated area in the Amazon AWS. First, so it will give the restricted area privately, so we can use the services of AWS it provides us. And firstly, we have to create AWS VPC, three-tier architecture VPC. This is the IP. And after creating VPC, the VPC should have to access internet through the internet gateway. So we need to create internet gateway and attach it to the VPC. Through the internet gateway and attach to VPC. So now VPC able to access the internet directly, and it will be useful for the public subnets to access internet directly, but for the private subnets we need indirect internet access. But while we are creating three-tier architecture VPC, defaultly it will create route table 3TA VPC route table, and also create security group defaultly 3TA VPC security group. Now, as I am showing in the diagram, we created VPC and internet gateway, and now we have to create the NAT gateway. While we are creating NAT gateway, it will also create the route table defaultly 3TA NAT. Here we have to select VPC, which is 3TA VPC, and create. It will create route table defaultly 3TA NAT route table. Now we created VPC and internet gateway and NAT gateway. Now we have to create subnets. 2 is public and 2 is private. For the subnets, it will use the route table. So we need 2 route tables. One is public and one is private. In the public route table, it have direct internet access. In the private route table, it will have indirect internet access. So we need to attach the NAT gateway to the private route table. Firstly, we will create public route table 3TA public route table 3TA route table and created. But here it have only local, so we need direct internet access. So we need to add internet gateway to this. And we created public route table. Now we need to create private route table, which it will need indirect internet access, which is NAT gateway. Private route table 3TA private route table. Now we created route tables. Now we need to create subnets. One public and 2 private in one availability zone, and another 1 public and 2 private subnets in another availability zone. Now we need to create 2 public in 2 availability zones. Public instance 3TA public subnet availability zone 1, and 0.26, and another subnet in another availability zone 3TA. Public subnet is 2, selecting availability zone 2 and giving IP range 26. Now it will take 64 IPs. It the second one, so we need to give second, which already one is allocated, so I'm giving second. We created 2 subnets, public subnets. One is availability zone 1 and another is availability zone 2. Now we need to create private subnets, one in 2 availability zones, one for both for backend application 3TA. Private subnet AZ1. Previously we took 1 and 2. Now we need to give 3. And private is created in availability zone 1. We need to create another private subnet in availability zone 2. 3TA. Private subnet AZ2 0.4.0.26 instance, and now we have public subnets into availability zones and private subnets into availability zones. Now we need to launch front end in the public application, back end in the private substance. So we need total 4 instances. Now we need to create instances, which is EC2 instance, EC2, but before the launching instance, we need to check whether the subnet is using associated route table or not. It will take defaultly VPC route table, so we need to check for the subnets whether it's using correct route table or not. For the public, it should have to take public route table, and for the private route table should take. Here it took VPC defaultly, so we need to change that. For the public, we need public route table 3TA public, so it take direct internet access. Public 1 over private. So it took route table defaultly, and change for this also. It is check. For the public, it took public. First we change the public route tables. Here public. For the private route tables, we need to assign private route table for the private subnets. So it will take indirect internet access, but it's taking local only, no NAT gateway. So for the internet gateway, for the route tables, we need to add internet gateway. For the route tables, private route table, we need to attach NAT gateway, so it will take indirect internet access. Indirect internet access. So one private subnet is over. Second private subnet, same default it took. Need to change to private route table, so indirect internet access, and save. we need to launch 4 instances, 2 in public, 2 in private. In the public instance, we need to run front-end application, and the back-end application is run in private subnets. Public instance AZ1 launch select. Here we need public subnet AZ1, correct only. For the public we need to assign public IP, and we not created security groups, so we need to create security groups first. We need 2 security groups, one is public and one is private. For the public we need SSH and HTTP, so we can access over the internet, through over the internet. 3TA public security group SSH and HTTP VPC, VPC SSH, what is PV4 HTTP. So by selecting HTTP and source anywhere, we can access the application running over the HTTP protocol from anywhere. There is no restriction that we can only access this application from specific IP only. So public, created public subnet and launch. One instance has been launched. We need to launch another public instance. PTA public instance AZ2 in availability zone 2. Same key pair and edit. Now here we need to select public subnet availability zone 2, and we need to enable public IP same. Here also same public security group and launch. Now we created 2 public instances. Now we need to launch private instances. PTA private instance AZ1, same key pair. For this we need to private subnet 1. We don't need public IP for the private subnet, and we don't have security group, private security group, that we need to create first. PTA private security group SSH. So for the private we don't need to add HTTP because we do not access over the internet. For the backend has to access, frontend has to access backend. So there is no public IP here, SSH only. Custom anywhere, change. Load and check there is a private security group. Select that and launch. Now until now we created 3 instances. Last private instances in availability zone 2. Private exchange availability zone 2. Check whether it's taking wrong subnet, so we need to select correct subnet, and we don't need IP, and we need to select security group which we have created before and launch. Now launch instance for only 8 but have more instances is launching. For now I need to terminate them and keep this only. TA private instance Z2 select keeper and submit to select security group, private security group, and launch. We requested more CPU capacity than your command limit allowed instances bucket. Only 8 is allowed, but here I have 4 only. Why is that? For now we just stop this. Stop this. Private instance Z2 instance insert security group and launch. Then we need to terminate one of that. Terminate. Terminated. Now we need to launch 3TA private instance AZ2 select keeper, select subnet, private, and launch. So we have created 2 public instances and 2 private instances. Now we need to launch the front-end application and the back-end application in these instances. First we need to launch public instance. Connect. We can connect over terminal. Search -i kp.pem file ec2 user @ this is the IP we need to take, public IP 154.3183. Yes. We need to check whether it's accessing internet or not through ping google.com. It's accessing because packets are sending and receiving. Clear sudo -i, switch it to root user, and I'm going to update the system. After the system has been updated, we need to install Nginx, which is web server, so we can access the HTML code over the web browser using the servers. So I need to go to a user share Nginx HTML. This is where index.file is available. It's have default file. Now I'm going to remove and give me a new file, HTML. Yes, and this is the front end application I have. Now this is the code I have. M index.html, insert, copy this. But before we are going to send, here we need to take the backend ALB, so that API calls has been done using this ALB name. Application load balancer for the backend, we need to create the application load balancer for the backend also. For now, just I'm taking copy, paste, and save, and run the Nginx server, and say enable the Nginx server. So even though I stop and start the instance, it will automatically run. So this is how. You need to check with this public IP whether it's running or not. HTTP. So this is the front-end application, but when I'm doing the API calls, it will call the backend previous ALB application, but it will not fetch any data. Calling the API call, but there is no ALB application load balancer with the DNS name. So I'm doing the same thing for the second instance also. Second instance, public instance 2, using this IP. Now I have to commit SSH 41. Yes, do the same process in google.com to check the internet is going, fetching data, packets are receiving. So internet is done. Now we need to update the system. We need to switch to root user before that and update the system. So we need to use application load balancer for the front end. So load is equally distributed among these two instances, front end instances. So once the front end is running in the second instance also, we need to create application load balancer for these two instances, public instances. Install Nginx.y. The second instance also Nginx is installed. Remove index. We need to go user share Nginx HTML ls. This file I have to remove first. Yes, vim index dot. Here I am going to add new file, new code, new front end code. In the index we need to add. After the ALB is created for the backend, we need to change that ALB name for the front end application so it can call the backend. Nginx name. After that, we need to start Nginx. Before that, we have to see whether it's running or not. HTTP front end is not showing because we not started the Nginx. Now we started the Nginx and we can access now. And we have to enable, so start and stop will not affect the Nginx started. Now front end part is over. Now we need to create the application load balancer for the front end. Go here, and for the application load balance we have to group these two public instances as one. So we need to create group with instances. We are going to create group, so 3TA front end ALB target group. So we are going, the back front end is running in the port number 80. Nginx will run in port number 80, so I'm giving 80 here. So this target group will check whether there is any application running in the port number 80 for the selected instances. 3TA VPC. Next, here we need to select public instances. So this target group will check on the port 80, is there any applications running, but Nginx is running, so this target group will check for 80 which is running Nginx. After the group we created, we need to create application load balancer using the newly created target group. 3-tier architecture, front end ALB. Now we have to select the VPC. In that VPC, these are the subnets. The application is running public, here also public. And security group, we need to select the default, which there will be HTTP, so we are able to access over the internet, so which is on the port number 80 only. So this is the target group, and create the load balancer. After the load balancer is created, using this the DNS name, we can access the front end application, but load will be balanced according to that. It will trigger the application instance 1 and instance 2 randomly, so load will be reduced in individual applications. There is nothing is showing, so we need to wait until here it have to show healthy, and here it have to show active. Once it is created, we need to create backend application. Before the backend application is run, we need to create database, which is RTS, using the NoSQL. So in the meantime, we create RTS on the RTS. So once RDS is created, database is created, we need to create one table in that. So after the database and table is created, we can communicate from the backend. So to communicate from the backend, firstly we need to have database. Aurora with full configuration. I'm using MySQL. I'm selecting full configuration, and for the free tier I can able to select only single availability zone DB, but in the most of the time we need to use multi availability zone. So one availability zone is crashed in real time, it will switch to the another availability zone and make it available all the time. But if I created availability zone in single, once the availability zone which I am creating is crashed due to some natural occurrences, my database is gone. So we need to select the multi-level. Admin 123 hash. Admin. Admin 123 star. 123 star. after we created for the database, we currently I'm not connecting to anything specifically, and I'm using this architecture and create new subnet group and new security group and create new. So I'm selecting new security group. For that we need to create new security group. Before that we need to create new security group. Let's create that first. Security groups. TA private SG public SG. Now we need to create security group for the database. So 3TA RTS SG, which allow my SQL. In the VPC 3-tier architecture, inbound role should be select MySQL, which is default 3306 port number, and for now I'm allowing anywhere, so I'm able to connect to the database from any instances. So I created. Let's reload and select again and check. There is a 3TA RDS security group, and there is a default available default certificate it's taking, and there is a subnet group. It will create a new subnet group. So let's take this and create the database. After while that creating, we need to check application load balancer is created or not. See, it's active. We need to check the target group healthy. Once we are doing this, it's taking S. So, yes. See, using that application load balancer, we are able to get, but we are not getting the data because we are not talking. Front end is not sending request to the backend, and backend is not talking to the database. Now we created the database. While once it's created, it will get the endpoint, one endpoint here. In the meantime, we are going to create backend instances. Backend application, Node.js application. So backend private application one. Connect. Exit. There is no public IP, so we need to go to public. From there we need to go to the private. So we need a PEM file there also in public also. So from there we are going to use PEM file and going to private subnet. So we are going to send a PEM file from Windows to that public IP, public instance. So public instance one, compute.pem ec2 user at the 35.154.31.83 master home.ec2 user. In this folder In this instance, in this folder, this pen file will transfer securely 100%. So we need to go, we need to once SSH to the public instance and check whether there is a file or not. Ls, see there is a pen file. We need to change the read and write permissions 400 to this pen, and ls, well, there is only read permission. Now SSH to using this pen file, ec2 user 10.0.1.23, and now we are in the second no, this is not a public private IP. We are going to go, this is the private IP we need to use. Exit 0.3.30. Yes, now we are in the private instance. There we need to switch to the user and sudo dnf install ria db not file. Yes, we need to install this MariaDB to connect to the backend. Let's check whether it's created or not. Still in configuration, that means it's created. Endpoint, take this endpoint, and this is the command. We need to connect to the backend host this endpoint user admin, which has password 123 hash. Yes, now it's connected. So databases, these are the databases. Now I need to create database MyDB. Now it will show in the MyDB. So using this MyDB, I'm going to create one table in it. Create table name students, create name where 100 age int branch where 100. Now we created table, show tables. Now we created student tables. Let's see what are the data in it. From students, there is no data in it because it's empty. Now created database and the tables. So now we need to create a backend application in the private subnet, and we need to create the API calls to the backend to the database. Exit from the database and sudo dnf update y updated sudo dnf install node.js y. So we need to create node.js application and run it. npm, both are created. Make the directory my API cd and API. In that API npm init y. Let's create one package.json and then install express, which is backend. It is the module to create a backend application, express.js, and we need to create CORS, which is cross origin service, and we need to install MySQL also, so it can able to write queries using MySQL to talk to the backend. Sudo PM2. It's because we can able to run this all the time in the backend. It will take some process ID, and it will run the backend application all the time. For that we need PM2. Start the file name. We need to create backend application. So we need to create app.js where backend will run. Backend JS will come. Insert. But we need to change do few changes. Here we need to take this endpoint, new endpoint, and a new password. 123 and save. Copy. Insert, pasting, and now I'm going to run this application all the time. App.js name my API. So it took that PM2 and it will run all the time, even though I exited from the run, and PM2 restart my API. Now we are going to check whether a backend is running or not. HTTP localhost. In that instance, whether it's running or not, we are going to check in the 3000 port. See, it's running. Students code out API running. So in the back, it's in the localhost, it's running. Now we are going to switch to the second instance and do the same thing and create the application load balance for these two backend applications and use that backend application ALB DNS name in the front end, and so that backend can communicate to the backend can communicate to the DB, front end can communicate to the backend. Private instance 2, this path 040444. Do the same process. DNF update y. Later I will tell you why we need to create application load balance for the backend also. Install y, because we can't directly access the backend, do API calls to the backend because there is no public IP and it's a indirect internet access. We are using the NAT gateway, so we can't communicate directly from the browser to the private. So it have to be from the front end. It should go to the internal application load balancer, and internally it have to communicate. So for that internal communication, we need internal DNS name for the backend, and for the front end, we don't need application load balancer to reduce the load. We are creating application load balancer for the front end, but for the backend, to do internal communication, we are going to create application load balancer. So in that group, it can communicate that within that VPC. npm will create one package.json and npm install express and cross, which is cross origin service. We can communicate to the backend from the front end over the internet. It will allow that cross will allow the process mysql2 and win app.js insert mode and paste the backend code. Save and sudo npm install gpm2 it installed pm2 start file name is app.js and name folder name is myAPI. So it will take that and assign one CPU, some part of CPU, and run all the time, even though I'm exited from the instances. pm2 save, it will save the list and start up, it will start the list and pm2 restart. This command only when any changes done in the application, but I'm running and check the same thing. http localhost 3000, it's running, so backend is done. Now we need to create application load balance for the backend and use that application ALP name. In the front end application and see 3-tier architecture, backend, ALP, target group. We are going to access only which are running in 3000 ports, so taking 3000, and we are taking 3-tier architecture and default route and select private instances. So this target group will only check which is running on the 3000 port number and create the application load balancer for the backend. 3-tier architecture, backend, ALP, instance, VPC, 3-tier architecture, VPC. Here we need to create public instance. So public, what are the applications running in the public subnets can only access to this target group. So for the security group, we need to create one security group. Security group 3TA backend ALP security group. It have to take TCP which are running on 3000 and will only take application request coming from the front end. So it will only should have to allow security group, public security group 3TA inbound role custom TCP. So it will take only on request from the 3000 port only from public security group. If we select the overall all port numbers, so it will take request from all port numbers with this port number only. Create security group and refresh, take only backend ALP security group port number 80 and select that backend target group. Application, there is no hyphen, 3TA backend ALP. Created. Now front end can do request over the 3000 port to the backend, but backend should have to accept, right? So we need to change the backend security group which is this. Here there is no rule to accept the request from the front end only, so we need to take that custom TCP. It can come from any form, only on 3000 ports, only from ALB security group. So it will take the ALB security group's requests only. So front end will call the application load balancer of the backend. Backend will accept the request coming from the front end over the application load balancer only. Public application backend application load balancer. So once I'm change this, we have to select whether it's healthy or not. And this part is done, we can do which will be impact, rating. Once this target group 2 instances are healthy and this application load balancer is active, we can use this DNS name in the front end and we can run. Once it become healthy, and we need to also check the application load balancer, backend application load balancer, and it's active. We have to take this DNS name and copy here in the front end application and change the front end application and see whether we can access or not. So new, save and copy. So we have to go here, public applications. cd user share lgx mx html ls remove index.html yes permission delete sudo remove index.html and sudo index.html insert paste new code and save as system ctl restart start
ఆ చెట్లు పాపం బయట పెట్టావన్నా వెళ్తాడు కదా అని బయట.